Hello, my name is J.Arena, and this is my embedded microcontroller's self-parallel parking car attempt. So this is my project up until this point. It's using one ultrasonic sensor of here, one low RPM high torque DC motor, a 5-volt servo motor to control the steering up at the front, and 12-volt battery, as well as the ordinary pick board shown here. So the way it functions is the DC motor back here would be connected to the rear axle of the car and drive it forwards and backwards. So I'll just show that I've got that working now by pressing this button up here. As you can see, it's turning in a way that if it was connected to the back axle, it would actually start moving the vehicle. Next is the servo motor. So to prove it's working, I'm going to press these two buttons here to turn it all the way to the left and turn it all the way to the right. So this button here will turn this all the way to the left. This button here will turn it all the way to the right. So it's got full 180 degrees of motion there. And what would happen in operation is it would be connected up to this steering column that I've got set up. So the way that this works is, if I just move the servo motor out of the way real quick, this little piece here would move side to side, and by it moving all the way to the right, you can see the front two wheels are going to turn like that. If I move it all the way to the left, as you can see, it moves it as such. It's a bit hard to see. It moves it like so. Due to the main material being EVA foam, it is a little bit too flexible to actually hook any of this up properly. So at the moment, it's just going to be a concept design. So all the individual sensors and actuators are working separately. That's proof there. Oh yeah, and the ultrasonic sensor here. So that was the actuators. Here's this ultrasonic sensor. So as you can see, there's a book off to the side here that is reading a distance of approximately 17 centimeters. If I bring the book a little bit closer, it'll correctly read the distance, how far away the book is. There's 8. Back out to 17. Okay. So that's them working separately. To get them to work together, what's going to happen is I'm going to press this button here, S5. The vehicle, this will start to move in the opposite direction. So before it was moving this direction, it'll move in the other direction to indicate it's going in reverse. The servo motor will straighten up, and the model car will attempt to move backwards in a straight line until this distance becomes larger than 8 centimeters. So if I'll just use the book again, once this distance reads 6 centimeters, 7, 8, once it's larger than 8, it will begin to turn in and do the actual park. So I'll demonstrate that it won't actually do anything at the start when the distance is less. So I'll hold this down and it'll start to reverse backwards. I'll give you a view of the servo motor while this is happening. As you can see, it's moving in the opposite direction, so it would be actually making it go backwards. And this will continue to move backwards until that distance goes larger than 8 centimeters. The reason that is 8 centimeters is, picture this car moving backwards. So it's going to stay there, but this book is going to move forward. And as this book is moving forwards, as soon as that distance goes larger than 8 centimeters, like so, it jumps up to 81 centimeters. As soon as that happens, it indicates that there is a spot available for the car to turn into. So what will end up happening is, by pressing the exact same button here, I will show it's going to move the car backwards the entire time, and you can hear the servo motor going. I'm not touching anything at the moment, it's completely automated. I'll do it again and I'll show you the servo motor automatically turning into the park. So turns to the right, straightens back up, turns to the left, and straightens back up. This will be, and then that will stop. I'll attempt to show this happening as if the car is actually moving with all of the pieces in it, it will be much slower than it would actually be in real life. But yeah, so the car will attempt to move backwards, turn to the side, straighten up, straighten that way, and straighten up again. And then that will complete the actual park and move in. It'll obviously be a little bit more exaggerated. I kept everything very small at this point. Oh yes, and to show that it will stay, so it won't move with the book there. The servo motor won't move, it'll just continue going into reverse. And then I'm just going to flick this book away and indicate this going higher, and it will start the park automatically. So there you go, 10 centimeters, and it starts doing the park. I'm not touching anything at this point. The park is completely automated, and it starts as soon as there is a gap in this ultrasonic sensor. So that's proven that all three of the two actuators and one sensor are all working together to provide an automated response. Obviously, if I was to do this again, I would use a material other than EVA foam because it is too flexible for the steering, as can be seen here. I'll just move this side to side again, like so. And if I was to try and connect that up, it's just going to squish into there, and yeah, it's just not going to work properly. And obviously with the battery sitting on the back, you can see that the back of it actually moves up and down with the battery sitting on it because it's too heavy. So EVA foam was a very poor choice of material in making this. But yeah, there you go. That's proven everything works individually and together in one go. Only thing that didn't get around to is creating a physical prototype that's capable of moving without me touching it. Obviously that's a poor choice of materials on my part, but everything works together and individually as shown by this presentation. Thank you.